Hello, this is Freddie Smith, and this is my submission for the Mechatronics and Mobile Robotics module assignment. First of all, I'm going to show the web bots, obviously here with all the objects search out and all of the other obstacles to avoid. See, the robot does roughly follow a square trajectory, but due to certain errors with loading and running a laptop, it doesn't completely load correctly. But as you can see in the code here, that's meant to run. I'll just move a few objects about so you can get a sense of how the avoidance works. But it's running quite slow with my poor laptop. Yeah, it's always going to spin around. For the searching algorithm, the robot slowly moves around all of the objects and into a new path until eventually it comes into the direction or area of the box where it will come to stop due to all of the code laid out here. Just quickly make this move so you can actually see them properly. See, the object's now been found as it says. I've now moved the object on top of the thing to test the force sensor, which should hopefully, if running correctly, display a quick message. Yep, see, the object's now on top of the robot. Force sensor's time is running. Due to errors of the code, could not properly get the return to start hour from working correctly, so it's been admitted. For section 2, this is the simulated force sensor, which is done with the creation of Wheatstone Bridge to represent the sensor under load. It also uses a 9-volt source with a regulator to regulate down to 5 volts to simulate the correct voltage and currents which would be output by the Arduinos. Now if I just quickly run it, this should hopefully output a 5 volts so that it can be crispy red by the Arduino input, as seen here on the oscilloscope screen. But if I now change resistance back to 1.3 like the rest, it should show lower voltage output. Yeah, as so. So when it is voltage high, it will represent the force input. This is the force sensor simulated in Tinkercad now, but with the use of potentiometer, the thing just uses certain components. But this is also run not with the other thing due to allow it to run better on my computer, or else it causes it to crash. So it's run now to show that the simple code that once it's changed up to certain value representing the loading on it, it will become active, as stated down here. Yep, and active. This is now a Tinkercad of prototype of the previous WebBots design. Quickly simulate it, the code to show that it's working and creating square and then circular motion. Now that it's run through all of square and circle trajectories, I'll just show you. When the force sensor becomes active, it will pause. See, it's held still when the force is active, same as in the code. And also, with the obstruction sensor, it will spin to avoid once something's detected from close by. See, now it rotates. It is just a comparison of the two sets of codes. There's obviously all set up. Here's also a combination of throwing square path and the simulated functions. The camera. This is the distance sensor for the fourth part of the assignment. As you can see here, here's timer set up sending out signal, which should be set to 6.7 kilohertz based upon my student ID of 210346693, but I've rounded to 6.7 kilohertz just for simplicity rather than 6693. So I just run this quickly. You can see it's running at roughly that, based on obviously the time. The distance sensor obviously using a current source due to the way the components work and seems not working correctly as intended. Obviously it's a simple band pass filter and a rectifier and a low pass filter, then just do another final amplifier to create a crisp output. So I'll go through simulating all sections. So as the voltage is coming out, which should be 6.4, 6.7 kilohertz from here, it's allowing the voltage to come through as intended. But if I now switch it to this, switch thing which should be outside the range, it won't let it through. Obviously, it takes a while to get operating. And so I don't know if I bring it up to about 7, which should just be about in the range. It lets it through, then I go up and over again. Should not allow it. Yeah. Now if I simulate the rectifier, it's obviously still catching up from that changing back. That's all operating normally. And here is the low pass filter, which should only allow in, which should be some bit of when I switch this. Should be able to prove it. Obviously, this is too high, so it shouldn't be letting anything through. I bring it down. Yeah, it should start letting it through as it's showing. Go a bit higher. Just outside the range, should tail off eventually, obviously taking off load, keep being thrown off out. As the further you get away, the less and less of the signal gets through. This I think the final width circuit. There, getting a voltage out. Obviously set to final, just crisp voltage coming out here. It's obviously dependent upon the current coming circuit, so if I reduce the current, there should be a lower output voltage. Which it has done, which obviously takes a while to get started, but yeah. Yeah, slightly smaller thing. This is my assembly drawing of what the final robot would look like if actually manufactured / prototyped. So it just simply uses two main components, this being one, which has structures, bevel load of the top half which slots into the holes, as well as having all the appropriate things like the Arduino here, distance sensors, and the DC modes which are there and on the other side. So it has an axle here to hold a front wheel to keep it more stable in the centre of gravity so it doesn't topple over and can properly move forward. There is the top, which also has a camera seeing the image and a force sensor, also products made by boxes, as well as holes to allow cabling to come down to the Arduino, as well as little rungs to keep the cabling nice and tidied away. This is fully assembled drawing, with obviously the wheel placed in with axles pull through to hold the wheels in place on both sides. Obviously, this should be more further pushed down to all the way into the slots, but just slightly exposed as to properly show the model at its current point in time.